Now, we are studying or having a quick revision of static electricity. Charge is a product of current and time. So charge can be defined as the product of current and time as well. If somebody asks you, define charge, define charge. You can define charge as product of current and time, but you cannot define current as the ratio between charge and time. And that is a very basic uh, thing that we do in physics, because basic quantities cannot be defined in terms of any other quantities. Now, first formula that I think you should be writing down is Q equals to IT, where Q is measured in coulombs, which are also ampere seconds. Current is always in amperes and time is always in seconds. Now, charge is a discrete value and it has an elementary value of 1.6 into 10 to the power minus 19. Minimum charge that can be there on an object is this, 1.6 into 10 to the power minus 19. The next possible charge is 3.2 into 10 to the power minus 19. So minimum charge is 1.6 and next charge is 3.2. And there are no in-between values between 1.6 and 3.2. Nothing can have a charge of 2.0 into 10 to the power minus 19. Or nothing can have a charge of 3.0 into 10 to the power minus 19. After 1.6 into 10 to the power minus 19, the next stop is 3.2. It means charge increases by steps, and that step is known as elementary charge. So this is another thing that you need to remember, that electron has negative elementary charge and proton has positive elementary charge. Charge on an electron is minus 1.6 into 10 to the power minus 19, and charge on a proton is 1.6 into 10 to the power minus 19. Okay. Now, another very important formula of finding charge is a product of number of charge carriers and charge on each carrier. So this is E, which is elementary charge. If we multiply it to the number of particles that have elementary charge on them, we get the total charge. So Q equals to NQ or NE. Both formulas are exactly same. Sometimes we use E, sometimes we use Q. And there is a very small difference as well. If charge on every particle is elementary charge, we can use E. And if it is any other charge, we can use Q. So till now, we have discussed three formulas: Q equals to IT, Q equals to NE, and Q equals to NQ. Now, charge has a field force. Charge can exert force on other charges from distance. It is not necessary for one charge to be physically in contact with another charge to exert force. So similar charges can repel each other, and similar charges can repel each other, yes, and opposite charges can attract each other, and they can do that from a distance, because electrostatic force is a field force. Now, field of point charges, for positive it is radially outward, for negative it is radially inward. Then what kind of field is there between two parallel plates? It is always parallel lines, equispaced from positive to negative. So what does these equally spaced lines are showing? They are showing a uniform field between the positive and negative plate. Okay. Now, if plates are not parallel, then this region is with a stronger electric field and this region is with weaker electric field. How do you think the diagram is showing that the field is stronger on the left side and weaker on the right side? Okay, think. Yes, lines are very close to one another. The field lines are close. It means field is strong on the left side and field lines are away from one another, it means field is weak on the right hand side. So if the plates are not perfectly parallel to one another, the field will be like this. Now we are coming to a next formula, which is electric field strength. What is electric field strength? Electric field strength is force experienced by a unit charge. Listen, if a charge object is brought to an electric field, it will experience an overall force, and that is because of the total charge on the object. But we don't want to know how much force is acting on the object. I want to know how much force is acting on a single unit of charge. So that will not be electric force, that will be electric field strength. So electric field strength is electric force acting on unit charge. If somebody asks you to define electric field strength, this is the definition. Electric field strength equals to electric force divided by charge. And the formula is E equals to F over Q. Okay. Now, if these are the two parallel plates and they are connected with a potential difference V and distance D, there is a different formula to find electric field strength. One is force divided by charge. Other is electric field strength is potential difference between the plates divided by distance between the plates. So now we have discussed 5 formulas. Q equals to IT, Q equals to NQ, Q equals to NE, E equals to F over Q, and E equals to delta V over D, where delta V is the potential difference and D is the distance. Now, electric potential. This is also a very important formula. Yeah. Electric potential is work done divided by charge. So energy per unit charge is known as electric potential. So if we need to calculate electric potential, we need work done divided by charge. So if you're making a list of formulas, you should be making list of, you should add this formula to the list as well. Here we have a question. Have you written all of the formulas, Usma Amir?
Yes.
Good. So you will need all those formulas now. I will be giving you a question. See, this is a situation. Okay. You have two plates. This is plate Y. This is plate X. Plate X is at a potential 400 positive volts, and plate Y is at a potential difference of potential of minus 200 volts. Okay. You can keep your microphone on because you are, I think, only student in the class who is discussing this with me right now. Anna and Amna, I hope you people are solving the questions.
Yes, sir.
Good, good. Now,
Sir,
this is plate Y, this is plate X. Plate X is at 400 volt, plate Y is at minus
Sir?
200 volt. Yes?
yesterday I came late and you were doing a question, so I didn't attend from the start. So
Today's lesson?
no, yesterday's. I'm here from the start today when you were recapping this all.
Okay, okay. So you are writing down all of the formulas that we did till
Yes.
now. Good, very good. Because this is all. This is all we need to know to solve any questions in this case. Okay.
Okay.
Now here we go. Let's see that can we apply the formulas that we have as a list with us. So now we have two students with me. One is Usma Amir, the other is Amna. Good. Mariam Wazir, are you comfortable in solving questions? She is not around. Like now, if positive plate is at positive 400 volt and negative plate is at minus 200 volt, what is the potential difference between the positive and negative plate? Let's see. Amna. What is the difference between positive 400 and negative minus 200?
600.
Sorry,
600.
100. Okay. What do you think, Uswa, Amir? Actually, whenever you have to find difference, what you do is you subtract them. So what will you get if you subtract minus 200 from 400?
600. 600 minus 600.
Sign doesn't matter. Sign does not matter.
Oh, okay, 600.
600. And Uswa?
600.
Okay, you should be swift with turning off the or turning on the microphone and doing this because we will waste less time then. Okay, the first question was what is the potential difference, and you two got it 600 volt. Now my second question is what is the electric field strength between the two plates? And we have done two formulas for electric field strength. One is electric field strength is force divided by charge. Other is electric field strength is potential difference divided by distance. Look at those two formulas and tell me which formula we can use to find out the electric field strength between these two plates. One formula is E equals to force divided by charge. Other is potential difference divided by distance. Which formula we can use in this situation according to the data given? Amna? Listen, you need to participate, whether you know or you don't. I'm here to help. I just want to know what you're thinking. So I cannot see with a microphone with a slash on
The
it.
second formula.
Good. And what do you think, Amna?
In the second formula.
Why? Why do we use second formula? One formula was force divided by charge, and the other formula is potential difference divided by distance. Why are we using potential difference divided by distance? Listen, the answer is because we don't know force and we don't know charge. So we cannot use the formula for electric potential, electric force and charge. So we have to use potential difference and distance. Now, get your calculators ready. Use that formula to find out the electric field strength between the two plates. It is potential difference divided by distance. The trick of the day is you have to convert centimeters into meters first. Hurry up. I hope you are doing it, Uswa.
Sir, I don't have a calculator with me right now.
You have this is the good thing about the online classes. You are at your home. Go get one. Hurry up. Or if you don't have one for this part, you can use your mobile phone calculator. But I will recommend that you go up because we are now about to deal with some very weird, some very horrifying numbers. So I recommend that you should have your scientific calculator. Alicia, you turned on your microphone. Do you want to ask something?
Yes, sir. How do we calculate mass in U?
Okay, listen. The value of U is a constant. It is 1.66 into 10 to the power minus 27 kgs. If you have any mass in kgs, all you have to do is you divide that mass with this number and you will have mass in U's. Can you write down the number? U equals to 1.66 into 10 to the power minus 27 kgs. So you can think 1 U is 1.66 into 10 to the power minus 27 kgs, and whatever mass you have, you can put it under 1.66, and you can put an X under 1 U, and then you can cross multiply and find the value.
Okay, thank you, sir.
Or you can simply divide the mass with value of U to get number of U's in any mass. Okay, Amna and Oswa, we are learning, and I need you both with your calculators. Tell me, what do we get if we divide potential difference with distance?
12,000.
Can you speak louder because your voice is very faint?
12,000.
12,000. Yes, it is 12,000. Good. What 12,000 what? Unit, please. You did potential difference divided by distance. What should be the unit?
What's
Go ahead,
V?
keep going. V is for the volt divided by.
Voltage per meter.
Good. Exactly. That is what I wanted to hear. Vm minus 1. Okay. Volt per meter. And Uswa, are you with your calculator now?
Yes, sir.
Good. Now, what is the force experienced by this electron, which is exactly on the negative plate? Do you see this electron, the red one? Charge on electron is written over here. I hope you can see this. The charge on electron is 1.6 into 10 to the power minus 19, and mass of electron is 9.11 into 10 to the power minus 31. Okay, we need these two numbers. Actually, they should be over here. Otherwise, they will confuse with other numbers. Now, listen. We have this electron. Can you find out force on electron? Which formula I should use? Now I have charge on the particle, and I know the electric field between the plates, and I need the value of force. Write down the data we know and we need. Write down. Electric field is 12,000 volts. Volt per meter. Then electric charge is 1.6 into 10 to the power minus 19 coulomb. And we are looking for force acting on the electron. Which formula we should use?
E is equals to F over Q.
Exactly. Amna, good. Now use that formula to find out the force experienced by E. And meanwhile, Uswa,
Yes.
do you know what to do over here if we are asked to find out force experienced by electron?
We'll multiply 12,000 with the charge.
Exactly. And how did you know that?
By the formula.
Good. Because there was another formula for electric field strength, which we didn't use earlier. And we don't need to use that for electric field now, but we can use the same formula for force. Good. Hurry up. Calculate the force on this one. Somebody just joined the class. It is Zareen Qasim. Can you unmute your microphone for a second, Zareen?
Yes, sir. Assalamualaikum.
Walaikum salam. Because you just joined the class. You are number one late, and number two, we are having a differential class today. Some of the students are solving the past paper question, and I have 2-3 students who are not familiar with this topic, and we are learning this topic as well. So, are you
Okay.
familiar with this electrostatics?
Yes, sir. I've completed the AS syllabus.
And then I have to ask a very important question. Are you for examination in May, June, or examination that is happening next month?
Sir, next month in October, November.
Oh, then you should not be in this class because I have another class where we just revise the topics very quickly and then we start solving past papers. Okay.
Okay, so like, is there a separate group for that I can join?
There is a separate group for that, and I shared a link yesterday to join the other group. Let me
Okay.
share the same. I think I shared that in this chat as well, but that will be gone somewhere. Just 1 second. Let me find out that link. And that is especially for the students who are appearing next month. I am not finding. Okay, I think I lost it. Let me generate a new link. Okay, I'm sharing the link in the chat.
Okay, sir.
This one, the Zoom chat. Okay, there we go.
Okay.
Did you get the link?
Yes, sir.
Just click on this one and you will be into the other group. And the class will start at 9 or 9:15, 9:10. Okay.
Okay, sir. So I'm just leaving this meeting then.
Okay, you can leave.
Okay.
Did you click on
Allah
the
Ye-
link?
Yes, yes. I've joined the group.
Good. So see you in the class at 9:15.
Okay. Okay. Allah
Okay.
Hafiz.
Allah Hafiz. Okay, students. Force on electron. Uswa and
1.92 into 10 power minus 15.
sorry.
1.92 into 10 power minus 15 Newton.
And what about you, Uswa? Did you get any answer close to that or different than that?
I got the same answer.
You cannot tell me that. You have to tell me your answer.
Oh, it's 1.92 into 10 to the power minus 15.
Good. That is how you tell me your answer. Now, if we know the force acting on an electron and we also know the mass of the electron, can we find the acceleration with which the electron will move towards the other plate? And what formula we can use for that? Do you know the famous formula that connects force, mass, and acceleration?
F is equals to ma.
Exactly. And can we use that formula for finding A? Yes, we can. We just have to rearrange. A equals to F over M. We know F, we know M. Mass of electron is given over here. I hope you can see that on the screen. Okay. Mariam Wazir, can you unmute for a second? I don't think so. Anna,
Yes, sir.
any problem in the question solving?
No, sir.
Good. Keep going. If you find anything like you need a formula or you want to know something, you can always interrupt the class. Okay. So,
Okay, sir.
okay. Amna and Uswa, did you get the acceleration?
Sir, how much decimal place do we take?
Three significant figures, not decimal place. Three significant figure maximum. Two are okay, but you can take three. They feel good.
Is it 2.11 into 10 power 15?
2.11 into 10. Yes, it is. Uswa?
Yes, it's 2.11 into 10 to the power 15.
Meter per second square. Physics answers come with units. Good. Now it means electron will run from this plate to that with an acceleration of 2.11 into 10 to the power 15 meters per second square. It is at rest on the Y plate. So initial speed is 0. The distance it is supposed to travel is 0.05 meters. Write the data down. U equal to 0. Distance travel is 0.05 meters. And acceleration is 2.11 into 10 to the power 15. And I want to know with what velocity it will reach the positive plate. With what
A is
velocity
equals
it will
to
reach
V minus U over T.
no, we don't have T. You think of some other formula. We have distance, we have U, we have A, and we are looking for V. Is there a formula or equation of motion only between U, V, A, and S? An equation that allows us to solve problems without using time? I can give you a hint. It has V square and U square.
V square is equals to U square plus 2AS.
Good, exactly. You can think of it as 2AS equals to V square minus U square to make it simple because U is 0. So that will make 2AS equals to V square. And then you can put the values in and get the value of V out. Oswa, do you remember this formula? 2AS equals to V square minus U square.
No, sir.
Okay, write it down. It is one of the equations of motion. 2AS equals to V square minus U square, where A is acceleration, S is distance, U is initial speed, and V is final speed. And in this case, we for electron know that the initial speed of electron is 0. The distance it travels is 0.05. Acceleration with which it is moving is 2.11 into 10 to the power 15. And final velocity is what we are looking for. So can you use that formula to find the value of V?
Yes.
Hurry up. As soon as you get your answer, you have to share it with me.